When installing a replacement electrical panel and the existing service entrance conductors are not long enough to reach the terminals in the new panel, splicing those conductors presents a specific set of considerations and potential code violations. Firstly, it is important to check the panel manufacturer's instructions. Some manufacturers, like Siemens, explicitly recommend against splicing service entrance conductors to extend their length within the panel. They often suggest using listed adapters specifically designed for this purpose. These adapters are intended to safely and reliably extend the existing conductors without introducing potential points of failure. Secondly, consider National Electrical Code, or NEC requirement. The NEC addresses splicing and the use of junction boxes, especially in service entrance applications. Section 230.46 of the NEC Splice Conductors specifies that service entrance conductors shall be without splice or tap, except as permitted in 230.43. That section lists certain exceptions such as clamped or bolted connections and metering equipment enclosures, and where the service entrance conductors are run to multiple service equipment enclosures. The allowance for splicing in 230.43 is primarily for instances where multiple service disconnects are required. Splicing to simply extend the length of conductors to reach the terminals of a single service disconnect is generally not permissible under this section without the express permission of the local authority having jurisdiction. Thirdly, the use of a junction box to extend the conductors introduces its own set of requirements. The junction box must be appropriately sized for the number and size of conductors entering and exiting it, as per NEC section 314.16, number and size of conductors in boxes. The conductors within the box must be properly spliced using listed connectors suitable for the conductor material, whether copper or aluminum, and properly rated for the amperage. The junction box must be accessible, meaning it cannot be concealed behind walls or ceilings without providing permanent access. The physical protection of the conductors and the junction box is also a key consideration. The conductors must be protected from physical damage, and the junction box must be securely mounted. In an environment where the box is likely to be exposed to physical stress, using a more robust enclosure is advisable. Regarding connecting the junction box to the new service equipment, this typically isn't a direct connection in terms of electrical continuity. The junction box serves as an intermediary point where the existing conductors are spliced to new conductors that then run to the service equipment. However, the physical mounting and grounding of the junction box are important. It should be securely mounted to a suitable surface, and if the junction box is metallic, it must be properly grounded according to NEC section 250. Grounding ensures that the enclosure is at the same electrical potential as the surrounding grounded surfaces, reducing the risk of electrical shock. When dealing with service entrance conductors, it is vital to ensure a low impedance ground fault current path. The equipment grounding conductor from the service equipment should be connected to the grounding electrode system, typically through a grounding busbar in the service panel. From this busbar, a grounding conductor should also be run to the junction box, ensuring it is properly grounded. Moreover, consider the ampacity of the conductors used for the extension. They must be rated to carry the calculated load for the service, as determined by NEC Article 220 Load Calculations. Using conductors that are too small can lead to overheating and potential fire hazards. Overcurrent protection is another critical aspect. The circuit breakers or fuses in the service equipment are designed to protect the conductors from overloads and short circuits. Ensure that the overcurrent protection is properly sized for the ampacity of the conductors. If the existing service entrance conductors are aluminum, using the correct type of connectors is crucial. Aluminum conductors require connectors specifically listed for use with aluminum, and they should be installed with an antioxidant compound to prevent corrosion. In contrast, copper conductors are more forgiving, but using the correct type of connector for the wire gauge is still essential. When splicing conductors, use mechanical connectors such as set screw connectors or compression connectors. These provide a secure and reliable connection compared to twist-on wire connectors, which are not suitable for larger gauge service entrance conductors. All connections must be talked to the manufacturer's specifications to ensure a proper connection and prevent loosening over time. Furthermore, consider the environmental conditions in which the junction box is located. If it is in a damp or wet location, use an NEMA 3R or NEMA 4 rated enclosure to protect the connections from moisture. This is especially important in areas prone to flooding or high humidity. Before beginning any electrical work, always energize the service entrance conductors by disconnecting the main breaker or pulling the main fuses. Verify that the conductors are de-energized using a voltmeter before touching them. Working on energized service entrance conductors can be extremely dangerous and potentially fatal. In addition to these considerations, remember that local codes and regulations may have additional requirements beyond the NEC. Always check with the local authority having jurisdiction, such as the city or county electrical inspector, to ensure compliance with all applicable codes. They may have specific requirements regarding splicing service entrance conductors or using junction boxes. If you are not comfortable performing this type of electrical work, it is always best to hire a qualified and licensed electrician. Working with service entrance conductors is inherently dangerous and requires specialized knowledge and experience. An electrician will be familiar with all applicable codes and regulations and will be able to ensure that the installation is safe and compliant. Using adapters designed for extending service entrance conductors is generally a safer and more reliable alternative to splicing. These adapters are specifically listed for this purpose and provide a secure and code-compliant connection. They typically consist of a terminal block or connector that allows you to connect the existing conductors to new conductors without splicing. The NEC also addresses the separation of different voltage systems within enclosures. If the junction box contains conductors from different voltage systems, such as 120 volts and 240 volts, they must be separated by a barrier or partition. This prevents accidental contact between the different voltage systems and reduces the risk of electrical shock. When running the new conductors from the junction box to the service equipment, ensure that they are properly supported and secured. Use cable ties or clamps to prevent the conductors from sagging or coming into contact with sharp edges. This will protect the conductors from physical damage and ensure a long-lasting installation. The proper grounding and bonding of all metal enclosures and equipment is crucial for electrical safety. Grounding provides a low impedance path for fault currents to return to the source, allowing the overcurrent protection devices to trip and clear the fault. Bonding ensures that all metal parts are at the same electrical potential, reducing the risk of electrical shock. In addition to the technical aspects, documentation is also important. Keep a record of all work performed, including the types of conductors and connectors used, the torque values applied, and any inspections or approvals obtained. This documentation can be helpful for future maintenance or troubleshooting. Remember that electrical codes and regulations are constantly evolving. It is important to stay up to date on the latest changes to ensure compliance. The NEC is typically updated every 3 years, and local codes may be updated more frequently. Consult the latest edition of the NEC and local codes before beginning any electrical work. Consider the impact of the installation on the overall electrical system. Ensure that the new service equipment is properly sized for the calculated load and that the existing electrical system can support the additional load. Overloading the electrical system can lead to voltage drops, overheating, and potential equipment failure. The correct installation of a junction box and the associated wiring is crucial for the safety and reliability of the electrical system. A poorly installed junction box can create a fire hazard or increase the risk of electrical shock. This includes ensuring the conductors are properly identified. Use colored electrical tape or wire markers to identify the different conductors, such as hot, neutral, and ground. This will make it easier to troubleshoot problems in the future. Furthermore, be aware of potential hazards such as asbestos. Older buildings may contain asbestos insulation around electrical wiring. If you suspect that asbestos is present, do not disturb it. Contact a qualified asbestos abatement contractor to safely remove the asbestos before beginning any electrical work. The selection of the correct type of junction box is also important. Junction boxes are available in various materials, such as metal and plastic. Metal junction boxes are more durable and provide better protection against physical damage, while plastic junction boxes are less expensive and easier to work with. Choose the type of junction box that is appropriate for the application and the environment in which it will be installed. The location of the junction box should also be carefully considered. It should be located in an area that is easily accessible for maintenance and repairs. It should also be protected from physical damage and environmental hazards. If the junction box is located outdoors, it should be weather resistant. Moreover, be sure to inspect the existing wiring for damage. Before splicing any conductors, carefully inspect the existing wiring for signs of damage such as cracked insulation, corrosion, or loose connections. If any damage is found, replace the damaged wiring before proceeding. When working with electrical wiring, always use the proper tools. Use insulated screwdrivers, pliers, and wire strippers to protect yourself from electrical shock. Never use tools that are damaged or worn out. Do not rely solely on the colors of the wires to identify them. Always use a voltmeter to verify the voltage and polarity of the conductors before touching them. Wire colors can fade or be mislabeled, so it is important to confirm the identity of each conductor with a voltmeter. When stripping the insulation from the conductors, be careful not to nick or damage the wire. Nicks can weaken the conductor and create a potential point of failure. Use a wire stripper that is properly sized for the gauge of the wire. After making the connections in the junction box, carefully inspect them to ensure that they are secure and properly insulated. Use electrical tape to insulate any exposed conductors or connections. Make sure that the electrical tape is wrapped tightly and completely around the conductors or connections. Consider the future needs of the electrical system. When installing a junction box, consider the potential for future expansion or modifications. Choose a junction box that is large enough to accommodate additional wiring if needed. Also leave some slack in the conductors to allow for future changes. Finally, remember that electrical work can be dangerous. If you are not comfortable performing this type of work, hire a qualified and licensed electrician. Electrical work should only be performed by individuals who have the knowledge, skills, and experience to do so safely. The most important thing is to ensure that the electrical system is safe and compliant with all applicable codes and regulations. This will protect you, your family, and your property from electrical hazards. Ultimately, adapters are the better choice.